Greetings, everyone. It's Professor Fiore back one more time. We're going to shift gears here a little bit, and we're going to talk about something non-electrical engineering-wise. We're going to talk about gerrymandering, something undoubtedly you've seen in the news. What the heck is it? How does it really work? People talk about it in sort of vague terms. I'm going to explain to you how it actually works. Now, you might be thinking, hey, wait a minute, Professor. You're a professor of electrical engineering. You're not a political science professor. What the heck is going on here? Well, from my perspective, I look at gerrymandering as essentially a basic engineering problem in optimization. So that's the attack I'm going to take on this. What do we mean by optimization when we talk about that? Optimization is essentially looking at a device or a system. You look at the parameters describing it, and you essentially trade performance in some areas for improved performance in other areas. So, for example, I'm going to design a car, right? Well, maybe I want to design a dragster. So I'm going to give up performance in areas like fuel mileage or noise, comfort, things like that, so that I can get maximum acceleration, maximum top speed, the things that are important to me as far as making a dragster. So when we talk about gerrymandering, what are the parameters? Think in terms of the vote parameters. What's the ideal case for voting? Well, ultimately, you want voting to be fair. You want all votes to be weighted equal. You don't want some votes to matter more than other votes, okay? And we would also like, equal access to voting. In other words, it doesn't matter if you're living in a city or if you're in a rural area. It doesn't matter if you're young or you're old. It doesn't matter if you're rich or poor. Everybody should have the same access to voting. Right? That's the basic idea in a democratic republic, which is what we have here in the United States. We vote for representatives, and those representatives go off to state houses or, the House of Representatives, whatever, and they vote for things, right? They create laws. They create things like environmental protections, worker safety, so on and so forth, right? So we always hear about, this person, this legislator, only got where they are because of gerrymandering, right? This district is heavily gerrymandered. What do we mean by that? Well, before I go on, first let me say that gerrymandering is an issue in state legislatures. It's also an issue in the U.S. House of Representatives at the federal level. It's really not an issue in some places, like, for example, the Senate. The U.S. Senate, everybody gets 2 senators. No matter where, what state you live in, you get 2 senators. So we can't really draw legislative maps to advantage one group or another in that case. Now, the entire Senate might be skewed because of, distributions of populations and so forth. But as far as a state goes, by itself, not so much, right? So it doesn't matter whether you live in the northeast corner of Maine or the southwest corner of California or smack dab in the middle of Kansas. You're going to have 2 senators, and you're also going to have 1 representative to the House of Representatives, right? There is actually one big exception to this rule. If you know what that exception is, throw it down in the comments, and we can have a nice conversation about that. But anyway, so the question is, how do we skew the voting so that one group is favored over another group? In other words, one political party over another political party. Well, this all has to do with how we draw legislative boundaries. So every 10 years, according to the Constitution, we have to go through a census. And the purpose of the census, a primary purpose, is to figure out where people live and then apportion the delegates, right, the representatives, accordingly. So we now have 335 million or so people in the United States. So we have to divvy this up right, state by state by state. Interesting little side note here. there's 435 congresspersons. When I was a kid, right, when I was young, in, let's just say 1970, the total population in the U.S. is slightly over 200 million. So we have like 65% more people now, but the total number of representatives hasn't changed. So in fact, each representative now represents roughly 65% more people than they did in 1970. Kind of interesting, right? That's a whole nother thing. Do you want that to happen, or do you want, to keep the number of people in a district per representative, right? You want to keep that constant. Well, currently we just keep the total number of people constant, all right? In any case, somebody, some group, somewhere, something has to decide on what the legislative boundaries are. And the trick here, the optimization, is to skew those boundaries in such a way that it literally optimizes against fairness. In other words, all votes being weighted equal. It turns out that some votes are actually going to be less heavily considered. There's a term they use for this called pack and crack. Okay? So how does this work? Well, what I'm going to do is I'm going to start with a very simple sort of situation, very simple, highly simplified state, right? And I'm just going to draw kind of a large rectangular squarish looking kind of state here, just to keep, I want to keep the visuals simple, all right? So here's our state. And to keep it super simple, and yes, we will dive down into this to look at something a little bit more practical, but just so that we can understand where we're going, what I'm going to do is I'm going to say that there's only two political parties, okay? And they are divvied up in our state in kind of an odd way. All of the people in one party are going to be on the right-hand side, and all of the other people are going to be on the left-hand side, or if you prefer, east side, west side. So I'm going to say, well, we've got two parties, right? I'm going to call about the yellow party. And I'm going to use a green party. So I got these little dots over here, and I'm going to say, okay, all the people that belong to the yellow party, they all live over on this side. Okay, so, just think of these dots, not so much as individual people, but, maybe just groups of people, just to kind of represent what's happening here in this state. Okay, so all of these people in the yellow party, because I don't want to use red and blue for obvious reasons. That whole thing is kind of stupid. Anyway, some of these, we'll just say, just to keep it a little bit closer to reality, we'll say some of these folks do live on the other side. And then we have this other color for the party, green, right? So all the green party people, they live on this side of the state. Well, at least the vast majority of them do. All right, same sort of deal. Yeah, I know. It's not really this way. But we're going to do this to understand how this actually works. Now, this is something we do in engineering a lot. We take a look at an idealization, right? A simple case. And then, we complicate it a little bit, right? Okay, so again, there could be a few people in the other party sitting out here. Okay, there you go. So here's the trick. What I want to do is divide this state up. And let's say it needs 4 legislative districts, right? Like for Congress, for example. Could be the state house, doesn't really matter. What you have to do is put the same number of people in a district, right? You can't put 1 million people in one congressional district and 500,000 people in a different congressional district in the same state. In a given state, they all have to be roughly the same size, not, down to the individual person, but they have to be roughly the same size. Now, it's also true that from state to state, there will be a little bit of a variation, right? You can't take just the total population, 335 million people, divided by the total number of delegates, representatives, 435, and come up with a number. And then use that. Because what's going to end up happening is the total state population won't necessarily be divided evenly by that number. And you can't have, 3.5 representatives. So some states actually, the individual size, right, the number of people in one congressional delegation might be a little bit larger or smaller than a neighboring state. But that's what we have to do, right? It's basically integer math that we're looking for that rather than, fractional floating point math. Okay, so I'm basically saying in my idealized state over here that the population density is smooth. No matter where you look, it's the same number of people per square mile. That's one way of looking at it, okay? And this is kind of an important thing to remember. In reality, that's not the way it works. There are a lot of states in the United States that have very low population densities compared to other states. In fact, there are some states, physically large states, like Wyoming, for example, that have fewer people in the entire state than many large cities, right? There's way fewer people in Wyoming than there is in, let's say, New York City or, Los Angeles or someplace like this. So clearly, population density in a real state is more complicated than this. But we're going to start here and move up, right? Anyway, so here's our state. Like I said, the population density is very consistent. And we have this kind of odd distribution of people, right? All the green people are on the east side and all of the yellow people are on the, west side, okay? It's actually more like a gold, isn't it? Okay, we'll call them the gold people instead of the yellow people. In any case, I have 4 legislative districts in this state. How do I want to divide it up? I can divide it up any way I want, okay? Mathematically speaking. Some ways are going to be maybe better in a fairness optimization than other ways. So one thing we could do is this, right? I could just say, well, I need 4 of them. So let me just make 4 districts, these sort of, kind of vertical sort of bars, okay? Now what we wind up with here are 2 districts over here where the yellow gold party, right? They have an outrageous majority. On the other side, on the east side, right, the green folks party, they have the same kind of situation. Yeah, there are a couple of green over here in the gold, and there are a couple of gold over here in the green, but for the most part, when voting comes along, you're going to wind up with 2 districts that are yellow gold, and you're going to wind up with 2 districts that are green. And that's it. Neither of these things is in any way competitive. Okay? So, are there other things we can do? Well, you could also do it like this. 4 districts. And you're going to wind up with the same kind of thing, right? Predominantly green, predominantly green, predominantly gold, predominantly gold. All right? Okay, so these are what we would call safe districts. You can't expect a green candidate over here really to get a lot of traction. Same thing over here. You can't expect, a yellow gold candidate to get a lot of traction. Well, there are people that would say, political scientists would say, well, this will lead to, a bifurcation of the population. In other words, it increases the partisanship, right? Because, if a gold candidate comes over here, he's never going to win. So what ends up happening is you get this sort of increasing ideological divide. All right, maybe that's not the best thing. Party might like it because they have safe seats. Is there something else we could do? Well, you could do this. I'm going to divide them up horizontally, right? Horizontal lines instead of vertical lines. Now what do we have? Well, each of these 4 districts are comprised of a diversity of voters, right? We've got a whole bunch of people in the gold party here. We got a whole bunch of people in the green party here. Same thing here, same thing here, same thing here. So each one of these 4 districts is highly competitive. And anybody who runs, who hopes to win, is going to have to appeal to not just people in their little group, but people across the board. And a lot of political scientists would say, well, that's a good thing. Okay? It kind of prevents extremism. Right? That's the argument that they might make. Okay, is that good? Is that bad? Well, I'll let you talk about that. I'll let you think about that. But it's not gerrymandering, right? Not in the classical sense. You know, there are some other things that you could do here, right? You could make lines that look like this. Yeah, and again, I know this is all highly simplified because of my square state and the distribution. But consider this. Well, now we have two safe districts, right? We have a gold safe district and we have a green safe district. And then at the bottom here and at the top, we have two, sort of, let's call them combative kind of districts, right? Where people are going to have to go back and forth. That's a sort of a mixture of what we had before. Is that better? Yeah, maybe. Now let's get into a gerrymandered state, right? So what I want to do, like I said, is make an optimization, but an optimization for essentially non-fairness. And here's how we're going to do it. So this state, right, basically is 50-50. It's 50-50 in terms of half the population being in the Green Party and half the population being in the Yellow Gold Party. Okay? Here's the big question. Who is drawing the legislative map? So let's suppose that the people, gold, right, the gold side, they're drawing the legislative maps. So here's what they can do to make things work for them, for their favor. Okay, so remember, this is a quarter, right? So we got to do 4 of these. So here's a quarter. And I'm going to divide this up in a slightly different way than we saw before. Okay, now what's going on? Now you might at first be a little surprised by this because you're going to look over here, right on the east side, and say, well, that's entirely green. Why would the gold party people just give up on this? I mean, boom, this is going to go to the green party, right? Well, if you look at each of these 3 over here, 2/3 of this is gold. Only 1/3 is green. Now, there's an old saying in golf. It doesn't matter if the swing takes the ball 200 yards or 1 inch. It's a swing, right? The size doesn't matter in this case. It's a swing. It's a stroke. So here, it doesn't matter if you win by 1 vote or 50,000 votes. If you win, you win. So statistically, the chances are, if people follow their party when they vote, gold over here is going to wind up with 3 seats, right? So gold is going to get 3, and green is only going to get 1. Yes, it's possible that, green could win here, but, you're at a 2-to-1 disadvantage. This is the essential idea behind gerrymandering. You pack all the opponents into one district, okay, and then the remaining people, you crack apart so they're ineffectual. Essentially, these votes in here, they don't really matter, right? This is completely unfair to these people, okay? It's also, in many respects, unfair to these people because, whether they go to the polls or not, chances are extremely high that, the Green Party candidate's going to win, right? And just, who cares? And over here, it's almost the same thing. The individual votes for the golds aren't really that important anymore. Your individual vote isn't so important because there's, it's the law of averages and large numbers. Okay? So this is not really good as far as democracy is concerned, right? A representative democracy, a democratic republic, would rely on the people voting for a representative to, sort of do their bidding, right, their wishes in the halls of the state capitals and the national capital, right, at the federal level. Instead, what we have is a situation where the party winds up maintaining control for themselves. Okay? They're not really accountable anymore. They've sort of, set up these lines in such a way that they're going to have an advantage, right? Now, in many cases, the party that has the majority of seats winds up controlling things like committees, right? Committee assignments, who has the majority, who's the head of the committee. They control the legislative agenda, what kind of bills actually get to the floor to be discussed, to be voted on. That's up to the majority party. So, hey, the gold group here, even though it's really 50-50 on the state, when you get to the representatives, well, it's 3-1. 3-1 instead of 50-50. You would expect, right, statistically, that the total votes cast in a given state, let's talk now about a statewide office, that the total votes cast in that state would be reflected in the seats. In other words, if a particular party won, let's say, 60% of the total votes cast across the state, you would expect that they would get somewhere around 60%, not necessarily exactly that number, maybe a little more, a little less, but around that as far as the total number of seats that were available, right? So if there were 100 seats, you would expect them to get somewhere around, 60% or 60 seats because they got 60% of the total vote. There are states in the country in recent years where that has not happened at all, where the courts have literally said, geez, these maps have been drawn up with nearly surgical precision to disenfranchise certain groups of voters. There are elections in states where one party got maybe 47% of the vote total across the state, but they wound up with maybe 55 or 60% of the total seats. And that's because of gerrymandering. All right. So, this is all well and good, but like I said, it's highly simplified. Let's take a look at something a little bit more, realistic. But, I'm not going to actually look at a true state. I want to look at something, let's say halfway, okay? Because you can see what's going to end up happening here. The sort of telltale result of gerrymandered districts. And I'm going to say right off the bat that really whatever party is in power should not be drawing the districts. But I'm also going to say that no individual party should be drawing districts. District drawing should be in the hands of a nonpartisan group or perhaps drawn by a computer program. We have ways of doing this. There are ways of writing programs that can draw legislative boundaries. There are certain characteristics that you find of highly gerrymandered districts, and we can design programs that, given inputs of the geography and distribution of population and so forth, that can draw decent districts. Okay, it's not a trivial problem, but it can be done. I really think it needs to be taken out of the hands of the legislature itself. Certainly the legislative group that's in power, because they're just going to manifest this over and over and over and over again. They remain in power, even if they're actually getting the minority of the votes, right? Anyway, so here's our new city. And what I'm going to do is I'm going to say, okay, we have one city, highly dense population, okay? And now let's make that a little thicker. Highly dense population. So they're kind of, all, I'm going to stick it down here, kind of like in the corner, okay? So lots of people. So you can imagine like all the dots I had before, and they were like spread out all over the place. right? So I'm just going to squeeze them all down into this one area. All right, so this is my city. Some dense population area, right? So in reality, you could imagine you're going to have, many cities, or it doesn't have to be a city, but, it's some high density kind of thing, relatively high speaking, compared to the rest of the state. And again, before I forget, there's going to be a few of these random things out here. And then the other group, right? Our old Green Party. Fatten that up a little bit. So they mostly live out here. Now, if I was doing this correctly, there would be an equal number of green dots and gold dots on the whole box in the whole state. I think that's about equal. I don't know. Probably pretty close. And of course, let's not forget, there's going to be a couple of these mixed in over here. Okay. Put another one right there. All right, now I have to go and do what we did before. I have to start drawing my district lines. And again, I'm going to do 4 of them. And we have to think in terms of equal number of people, in other words, equal number of dots in our case, in each district. And I'm going to gerrymander this. So again, we're going to say that this cluster here is roughly equal to all the dots out in the periphery. Okay? So kind of like the diagram we ended up with before, except that all of the things that were over here on the east side are all, put together over here. Okay? So how do I draw the line? Well, I would probably do something like this if I'm trying to keep my gerrymandering alive. So here's one district. And this is going to hold, about half of the total number of people in this gold area. Okay? And then what we're going to do is the remainder of this, right? That's the pack part. We're going to take this part and crack it apart into 3 pieces to weaken it. Okay? So, I don't know, maybe we'll just do something like that. I'm purposely making this looking like really kind of crazy, because there's a method behind this madness. All right, so we've got, let's see, there's one in here, there's 2 over there. Maybe I'll do something like that. What do you see? Well, they're kind of strangely drawn, first of all. But again, if I look at any given district, right? So here's a bunch of gold, but there's a whole bunch of green out here to compensate for it. And in this district, well, there's some gold here, and there is green over here. And if I did this right, that'll balance out correctly from my perspective, having, more green. And then this thing is out here. It's, obviously going to be more green. Another thing we could do, I'm going to keep this kind of similar, because there's, more than one way to skin the proverbial cat, right? So we could maybe do something, let's see, like this. And then, let's see, we could take, I don't know, maybe right here, do something like that, okay? So this drawing might be a little bit easier to see. right? Obviously one packed district here. Here's another district out here, right? Lots of green, a little bit of gold. Over here, lots and lots of green, a little bit of gold. Over here, lots and lots of green on the bottom, a little bit of gold. So in this example, like in the preceding example, what we see is some kind of strangely shaped districts, you know, because they're sort of tortuously drawn in order to capture, first of all, this major piece, right, the pack, and then we have to kind of squeeze in this remaining bit to crack them apart, divvy them up into the other districts, okay? So we still have 4 districts. They still have the same number of people in each district, roughly speaking, but we're back to that situation where, hey, one party is going to get 3 seats, most likely, statistically, and the other party is only going to get 1. But, okay, that's gerrymandering. Now, when you start looking at this in a more realistic thing, where you have multiple cities and there's other kinds of geographical obstructions and so forth, things start to get pretty strange looking. Okay, it gets much more complicated than this. And trying to set up the districts it's going to lead to really odd kinds of things. You know, my first drawing, we had very simple kind of districts, right? They're like squares, basically, rectangles. And even in the second version, they weren't insane. They were definitely a little bit tortured. But the sort of signature of a highly gerrymandered district is something that might look like, I'm just going to draw something out here. You know, it might look something like this. You know, I mean, really wacky looking. You know, not anything even close to, you know, maybe a normal shape. Like, you know, you don't expect things to be like perfectly, oops, that's kind of ugly. You don't expect things to be, you know, like nice circles and squares and stuff. I mean, things are going to follow, you know, like rivers and whatever. But, I mean, look at this thing. It almost looks like a crazy person dancing. You know, here's a foot over here. There's a foot down there. I don't know. So the telltale thing over here, you know, you've got a highly gerrymandered district. All you have to do is look at the ratio of the border, right? What's the length of the border? Like, so if you got in a car and you drove this border, okay, you compare that to the area encompassed, right? What's all this area in here? If there's a really high ratio of border to area, it's most likely a highly gerrymandered district. And these are the kinds of things that you will find, because it will just happen to work out that, you know, lots of, in our case, right, lots of greens live in these areas. And there's, you know, many reasons why they might. You know, historical reasons, economic reasons. You know, there's all kinds of reasons why people might live in a certain area. It might be because historically they were barred from living in other areas, you know, like redlining, you know, things like that. So you find, you know, a couple out here. But that's where most of them are. And then, you know, our other group over here, we find very few in these areas. All right, just a few out here. But most of them are, you know, out in these other areas. Right? And on and on and on we go. Hey, this is fun. Okay, and then of course, you know, you have the intersecting boundaries for the other districts, right? So, you know, maybe there's another district that kind of comes in like this, It comes out and captures all of this. Okay, so now you got kind of a weird district. And then maybe there's another district, because maybe there's a big green area down here, right? So they want to only capture a little bit of that. This version is like the pack version. And then over here, if there's a lot of green down here, they might do something like, well, we'll capture a little bit of that, right? So that, we can crack that set of votes, but we'll have most of this. So like I said, we start to get these really weird kinds of shapes, right? Like I said, you could create computer programs that could draw these border lines and so forth, where this ratio is, within certain constraints. All right. You need to take this out of the hands of the people who are going to benefit, because it's a negative optimization as far as democracy is concerned. Okay. If you like democracy and you like the idea that all votes should be weighted equal, you don't like gerrymandering. So that's basically how it works, right? This is not a trivial thing somebody's going to do in an afternoon, not unless they have a fancy program that's literally optimizing for the bad stuff, okay? But that's essentially how it's done. So, as usual, you have any questions, comments, put them down in the comments section of the video. Take care. We'll see you next time.